In this video, we will show you how to integrate annotations to metadata records in Mint. The annotations may have been produced by a dedicated tool such as Sage, which is also the example we consider in this demo video. Mint offers an interface that allows you to filter the annotations by various aspects, like the confidence the annotator had in the work, a potential human review of them, or specific URIs that should generally be accepted or rejected. Let's first have a look at what an annotation looks like in Mint. In essence, an annotation is an added piece of information to a metadata record that is not produced by the original data provider, because if he had extra information, he would probably put it in the record. This extra data can either be produced by a software agent with an algorithm, like an automatic translation or an image or analysis where you detect objects or color, or by humans, maybe via a process like crowdsourcing. The information is then encoded in JSON format. Mint accepts various kinds of JSON formats. Either you can give it a simple JSON text file, or if the file becomes big, it makes sense to zip the JSON file, or sometimes if your machine produces many different JSON files, you can provide them in a tarball. An annotation contains different kinds of information. The most important part is the URL or the text that you want to add to the record. If you just add literal text, it typically is useful to mark it with the language. Most of the time as well, it is necessary to provide the record ID with the information so that the system knows where this information belongs to. But in extreme cases, it could be possible not to provide the record ID. For example, if you provide translations, where the actual information that you need to apply the translation is the original text. It should contain the field name under which the annotation should be provided. Like you want to add the information to DC subject or to DC format. This Mint calls this field the target field. It should contain the creator, which is either a person or a bit of software. In Mint, that is called the annotator type. If it's software as annotator type, you can further specify in the field annotator name what kind of software or what version of software it was. Additionally to the field where the information should go to, the annotation can provide the field where it extracted information from, the analyzed field. For a literal, that would be a field that contains some literal value, maybe that you wanted to translate, or where you performed a named entity recognition process. And for an image, you should see there a field name where typically image URLs can be found, like EDM is shown by or a web resource. Annotations are usually done with some form of confidence attached to it. Either the algorithm of the person that did the annotation is not confident at all, that's a 0, or is absolutely sure, that's a 1.0. And finally, annotations, when they were created by a software, are sometimes reviewed by humans, which may say they accept or reject the annotation. And we support as well to give some kind of confidence score to this bit of information. So the human can say, I am 0% confident that this is rejected, or it's 100% sure that this is accepted. Now let's go through an example of an annotation set that should be filtered and applied to an EDM XML file. Mint supports annotations in a Europeana defined annotation format from tools like image analysis, crowd heritage, or, like we will demonstrate now, from Sage. First, we log into Mint. We have made a test account here, and we have prepared an enrichment on the Sage platform. For that, we go to Import New Enrichment and provide the URL for the enrichment. The upload will appear here and will take a few minutes. Once the enrichments are uploaded, we have a few options right from the list. We can see here the annotations have finished uploading. We can decide to delete the annotations. We would do this if the annotation upload, for example, failed, or if we want to do some housekeeping and this set is maybe updated and we don't need it anymore. We have access to some basic statistics. There's a list of all the fields that Mint recognize in annotations, and we can have a look of what is contained in there. For example, the annotator type contains the value software in all of the records. And since software did the annotation, we would expect somebody filled in the annotator name. And indeed, there were 2 annotators involved in annotating the set. Other values of interest would be the record ID, which tells us which records were annotated more often. This record, for example, contains 22 new annotations, and altogether we have 8,120 records that are annotated. We can see which fields the annotations should go to. In this case, it would be subject and spatial. We can see if humans have reviewed the annotations, and in this case, 16,000 were marked as accepted, and 5,400 were maybe not reviewed. We can see the confidence values, which is not particularly useful, but maybe to see that 15,000 annotations were not marked with any confidence values. The analyzed field is not filled in from both annotators, but presumably title or description was annotated. These are the URIs that the annotators use to annotate the datasets, and we can see that 120 different URIs were actually used for annotations, and some more often, 1,800 times, and altogether 21,000 annotations. We can get a small statistic that's separated by target field, and here we can see that we have 13,000 annotations that went to subject and 7,600 went to spatial. We can see as well the number of distinct annotations per target field and the number of records that were actually annotated per target field. The next thing you can do is inspect every annotation one by one with the magnifier glass. You can click through all of them and see the values. This might be or might not be useful for your use case. But obviously it's not very practical to click through 20,000 annotations to inspect them one by one. The final thing you can do from the list view is you can copy a link to this annotation for download into your clipboard. With this link you can share this annotation with somebody else. We have made this link expire fairly quickly to keep your annotations mostly private. If you want to use them hopefully within a day or two. The most important thing you do with annotations, though, is you apply them to a dataset. For that, you need to select a dataset. To select the dataset where we want to apply our enrichments to. Theoretically, enrichments could be applied to any dataset. Sometimes you have multiple versions of the same dataset, so it is your responsibility to decide which dataset you want to apply the enrichments to. We know this is the dataset where the enrichments were created, so we select this one. Here you can see that the dataset has already been enriched during the crafted project. During an enrichment, a new dataset, a derived dataset, a transformation is created that contains the annotations inside the EDM. The original dataset is not modified. We will now select the enrichment that we want to apply. Automatic enrichments often make systematic mistakes. Mint gives you some simple options to remove these mistakes. This is done in the filter chain. At the moment, the filter chain says accept all annotations, which is the simplest filter chain. And if you submit this, all annotations will be used to enrich the dataset. However, you can apply filters. The method how this is working is that every annotation walks down this filter chain from top to bottom. At the moment there's only one option. And at each step it can be either accepted, rejected, modified, or nothing is done to it and the next step is executed. Let's build a simple filter chain. Imagine for a moment that we don't want to have any of the annotations that are not created by humans. So what we want to do is we want to reject all the annotations that were not accepted by humans, or inversely, we want to accept all annotations that were created by humans and reject everything else. This can be done by creating a basic filter. A basic filter can take a single thing from an annotation contained in a field. In this case, we want the review field. It can apply a function to it. In this case, we want to say equals. And normally functions contain parameters. The equals function contains one parameter. We have built a basic filter that compares the review field of an annotation with the word accept and says true if that's the case or false if that's not the case. We can use this basic filter now in the filter chain. Instead of accepting all annotations, we will accept only annotations where a review list is equal to accept is true. The rest of the annotations we want to reject. And we could submit this and only the human accepted annotations would be applied to enrich the dataset. Let's get a little bit more creative. Imagine for a moment that we don't like that a humanly reviewed annotation is declared as created by a program. We want to say it's almost the same as if the person has done it. We can create a new basic filter that says the annotator type is actually a person. This is not really a filter. It sets the annotator type to person. Now we could modify our filter chain and says every annotation that starts in here will be modified by setting the annotator type to person. Now obviously we don't want annotations that were not reviewed by humans to say they were created by a person. But since we are removing those anyway, it doesn't matter. Let's add another change. We are fairly certain that an annotation that a human has reviewed is correct. We want to say that the confidence for those annotations is 1. So we can take the confidence field and set it to 1 in the basic filter, and then use this basic filter to modify all annotations and set the confidence to 1. Now, sometimes we need a little bit more complicated operations than just doing one thing. For example, we have observed that the thesaurus annotator in this case makes a certain systematic mistake. One of the terms he annotates the dataset with is always wrong. We can do this by add a filter to check if the annotator is the thesaurus annotator. That's not the complete name, so we don't use equals, we use contains. But we don't want to do anything just with the thesaurus annotator. We want to actually look at a certain URI that it annotates with. We need to create another basic filter that looks at the created URI, and we know that a certain annotation that contains this string is always wrong. So what we want is we want to reject an annotation when it comes from the thesaurus annotator and contains this URI. Both have to be true. And to implement this, we can use a combine filter. The combine filter does exactly that. It can AND or notations together or build simple if-then constructs. In this case, we want to do an action rejecting when the conditions D and E are true. Let's try this. AND D E. So the filter F will be true when D and E is true, and D says the annotator is to thesaurus, and E is this is a certain UI that it annotated with. Now we want to reject those. How do we do this? We create another condition and say we want to reject all annotations where the filter F is true. Once we are happy with all our filters, we can submit the job. And after a while, the enrichment will be done. Currently, it's operating. By the magic of video editing, the process that takes a few minutes has been completed. If you go into this enriched dataset and you open the details, you get a small report of what has happened. In this case, unmatched counts all the annotations that have not found a partner and those, additionally, that have been filtered out by our filter chain. We can see that we only annotated 37 records with spatial information. We had a lot of duplicates. We only annotated 26 subject records. Altogether, only 60 records have been annotated with many duplicates. And most records have not been annotated. But this is only an example dataset. Hopefully, your own experience will be better. And this concludes the explanation video for enrichments in MIT.